All right, so I'm going to show you a couple ways to use your calculators. So I'm going to show you how to do this by hand first because they are both numbers that are values that are easy to work with. But then I'm going to show you how to use your calculator because sometimes you might get numbers that aren't quite so easy. And so let's take a look at the first one. If you're given the vertex form, it winds up being a pretty straightforward solution, right? If you sketch a little bit of what you have, where is the vertex going to be located for this graph? The x-coordinate of your vertex is -4. The y-coordinate is 3. Okay, so you're looking at -4, 3. I labeled this above because I can tell from my leading coefficient that this is opening down. So all I need to know is this information here. I don't need to be any more precise than this. So this is my sketch. And so I know from my domain is always going to be -infinity to +infinity. And my range, I can see here because it opens down, the vertex, the y-coordinate of my vertex is the highest possible point. It's a maximum. So I'm going to go from -infinity all the way up to that, and it will include that. So which of these coordinates do I use, the -4 or the 3? It's y-coordinates, right? Range is the outputs, so 3, and then a bracket at 3. So this would be my domain and range for that problem. These ones you should always do by hand. Okay? All right. For the second one, though, there's some options on how to approach it. Okay? The first is you do need to know where your vertex is. So if you are looking to find your vertex here, your vertex is found at -b/2a. You can plug in your points. Your b value is a -8. Your a value is a 4. The negatives cancel, and what you wind up with here is 8/8, which is 1. So there's your x-coordinate for the vertex. That doesn't give us any direct information, but it allows us to find what the corresponding output would be. Okay? And so if you evaluate f of 1, to get the y-coordinate of your vertex, you get 4 times 1 squared minus 8 times 1 plus 2. So 4 minus 8 is -4, plus 2 is -2. And so you get your vertex. Once you have your vertex, you now identify, is our graph opening up or down? It's a positive, so we know it's opening up. So our graph is going to look like this, with the vertex being the absolute minimum point. And so the domain, no problem there. It's always going to be all real numbers. But the range here, it starts at this lowest point of -2. Again, we're using the outputs or the y-coordinates. And it extends all the way to infinity, a bracket at the -2 because that is included. All right. What I want to do is I want to show you another method you can use to find a vertex. Right? And that's using your TI-89. Okay? And we haven't talked about using the graphing tools yet for this. So if you go into your TI-89 and you enter this function in your Y editor. So if you hit Diamond F1, access your Y editor, and you type the equation 4x squared minus 8x plus 2. Okay, so now my quadratic function is stored in my Y1 equation. Okay, what I can do is I can go, if I hit Diamond F3, I can take a look at its graph. Okay, so I'm going to go ahead and change my window setting here too. All right, so if I look at just what the graph of this looks like, here is the sketch of my graph. I can see right here is my vertex. If I want to find what that vertex, the set of coordinates are for that vertex, the way I can do it is use this Math tab inside my graphing utility. And I can choose, is my vertex going to be a maximum point or a minimum point? It's minimum. So I'm going to choose the minimum point. And now what it's basically asking me to do is it's asking me to determine an interval over which I'm testing this graph. So I need to set a lower bound and an upper bound. The lower bound is the somewhere to the left of my vertex, so I can hit enter. My crosshairs are to the left, so I can hit enter. And then I'm going to just slide my cursor, as it's asking now for the upper bound, somewhere to the right of, anywhere to the right of that vertex when I hit enter. It's going to give me the x and y coordinate of my vertex. So I see right here the 0.9 repeating is approximately 1. The y coordinate is -2. So I confirm that I had the right vertex from that. Okay, but again, you might want to use this in order to find them if it's not so easy numbers to work with.
What's your window here? Because my graph's not showing.
So if you hit diamond F2, the default window settings should be -10 for the minimums, +10 for the maximums, scales of 1.
You can also just do zoom fit.
I wouldn't. Sometimes it'll zoom into just like a quarter of the image, and so sometimes it's hard to see. All right. So let's say you weren't going to use the graphing utility to find the vertex, but you still want to use your calculator. Okay, I would still put this into the y editor like I did. So this is now, again, my y1 of x function. Okay, and so what I can do is I can still do all of the same evaluating I did right here. And if I know my vertex is going to be located at the following point, right? So here, the coordinates of my vertex from this general form are going to be -b/2a, and then the function evaluated at that point. Okay, so what I can do on my calculator as well is I can take this calculation here, and I can take a -b. My b value is -8, divided by the quantity 2 times my a value, which is 4. So again, they might not always be such easy to work with numbers, but if I calculate that, I see that it's 1. And I can then go into my y1 or my function notation, use y1 of whatever that happens to be, and now I'm going to evaluate it, and I get my corresponding y coordinate. And so that's the way I would use my calculator if I was doing this with, again, unfavorable numbers, the ones that aren't that don't come out to be nice, easy integers. Okay, but you can still do that process.